I'm Sean from Kitestring Data, and today we're going to go through the main tech that we use for data development. It's all Microsoft Azure. We'll do deep dives later, but this is just a whistle-stop tour of the tools of the trade and how we use them. SQL. Wait a second, I'm sure I heard a groan from the Python fans. Python is at number 6, so just relax. There's 5 bits of tech we need before we get to Python, because we're not going to find clean, curated, beautiful, automated, recent CSV files out in the wild. Some companies might have them, but I've never seen one. I've only found source systems that can be a bit mucky. So SQL is number 1. SQL is the language of databases. Developed in the 70s, it's got a boxy, brutalist architecture vibe to it. It's not pretty. It's not going to make your friends jealous. It's for moving and matching and cleaning and storing data. You can't build websites. You cannot make a physics engine for your latest video game. You cannot hack into your biotech implants. It is not down with the kids, and that's just fine, because SQL is only for doing brute force operations on large volumes of data. SQL is ancient as tech goes. It's almost 50 years old, so it hasn't changed that much since before the internet was invented and computers look like this. So if we were looking for an analogy to the animal kingdom, SQL would be the equivalent of a crocodile, which as a species haven't changed that much since the Jurassic period. SQL has lasted for exactly the same reason that crocodiles have lasted, because it's fiercely competent in its niche. It's fit for purpose in the biological sense, for moving, matching, cleaning, storing data. It's important to have something tried and tested, something experienced, fighting in our corner, because some of the data we're going to find in the source systems isn't going to cooperate, it's going to put up a fight. SQL has been winning exactly these kind of fights for 50 years. And every now and again, there's some ambitious new project where I'll get some kind of telemetry data or some kind of massive, huge log data. I'll send it to SQL and I'll think, there's no way. There's absolutely no way that SQL is going to cope with it. And it always has. It is built like a tank. This is where we're going to build our home, our base, our database, or more specifically, our kitchen, because we're going with a restaurant analogy today. Power BI. If SQL is the kitchen, Power BI is table service. It's the candlelit, fine dining experience, front of house, what the customers see. Power BI is a dashboarding tool that can read clean, useful data and make colourful, interactive, web-hosted dashboards that help people answer fundamental questions frictionlessly. Power BI is not SQL. It's a young whippersnapper, less than 10 years old. It's glamorous, it's desirable, it's hot stuff. When you think about your favourite superstar CEO or world leader, they're looking at their Power BI dashboards, and the people around them are looking at their Power BI dashboards. You can look at Power BI dashboards after you've sorted your SQL. Datafactory. Lift and shift. Currently, we have a great, powerful, empty kitchen, and you need to move data into it. For our restaurant analogy, Datafactory is the delivery van. It has a source sync approach. So on the source side, you've got loads of integrations to on-prem and cloud-based systems. You can grab what you need and you put it into the loading bay of your SQL database for validation and cleaning. Logic apps. Earlier, I might have talked up SQL a little bit, but we should be honest, SQL does have quite a lot of shortcomings, being a language that is strictly limited to data movement. And unfortunately, those shortcomings aren't all exotic gold-plated luxury language packages to help you reverse engineer designer babies. Some of the missing features are just core bog standard functionality that could come in really handy, like send an email, or schedule a process, or respond to a webhook, or post to a Slack channel. Logic apps are serverless bits of compute in the Azure ecosystem which are super easy to design with a drag and drop interface, and they integrate with loads of other services. They're lightweight, they're reliable, and cheap to run. Fill in some of those functional gaps that SQL has. Datafactory again, right back. We're almost at Python, but before we get there, we can massively upgrade our capabilities without learning any new tech. Just using Datafactory. Until now, this data processing system is a read-only reporting system. It's just a passive observer sitting in the corner like a wallflower, soaking it all in, but it has no impact on any of the source systems other than some drop-dead gorgeous Power BI reporting and associated actions and insight. We can repurpose Datafactory to change all that without learning any new tech. Datafactory is source sync, And you can swap the source and the sink. So you can write back in to those source systems. Reverse ETL, it's called. Comes in really handy if you want to tag any of the data integrity issues for review, or perform a complex calculation in your mighty SQL environment using the time available with a thorough batch process and write that back. Or you can just use it to migrate data between systems. 6 is Python, 7 is Python 2, but 6 is Python ETL, extract, transform, load, with air. Python is fantastic. I know why people are fans of it. For those who don't know, Python is a general purpose programming language introduced in the 90s, which has grown into the leading sophisticated data processing language through the introduction of amazing libraries like NumPy, Pandas, scikit-learn. It's general purpose, which basically means there's no limit. It's a full off-road vehicle. You can use it to capture statistical regression, or send a rocket to the moon, or upload your consciousness into the singularity. It's got absolutely everything available to it. Here at Kitestring Data, we have a rule. Python will not replace SQL. So if SQL can do it and Python can do it, SQL wins. SQL is our home base, and Python has to fit around that strategy. The first really useful thing Python can do, number 6, is bring us great data that we can't get through Datafactory. There are gaps in Datafactory's integrations. Web scraping is a massive one, but sensor data and any unsupported systems, Python can get hold of everything that Datafactory can't and deliver it into the loading bay of our SQL database. Number 7, Python ML, machine learning. The other thing that Python can do to assist our SQL home database is to use the statistics and machine learning libraries. Python doesn't have any true artificial intelligence libraries yet. Unfortunately, artificial intelligence is still written exclusively in PowerPoint presentations, but there are loads of applications for the machine learning libraries that do exist in Python, and as soon as AI does exist, there'll be a Python package for that too. Number 8, Databricks. Finally, there's Databricks. I might have over-egged the pudding slightly, only slightly, when I said SQL was indestructible. Occasionally, you'll need to scale up. And the way to scale up is to use a Spark cluster to handle something massive, something truly humongous. Databricks comes in really handy for those rare instances where SQL databases would be insufficient. But you use the same SQL and Python, PySpark, programming languages inside Databricks. That is a complete picture of the data tech landscape as we see it and use it. You might agree, disagree with some of it. Please leave that in the comments below. We are revising this. And if you're still here, you obviously like the video, so why not make it official and help the algorithm? This video is sponsored by Kitestring Data, which is a growing data consultancy in the north of England. We're always looking for friendly, talented data professionals to join our teams, and we're also looking for new clients who want to push the boundaries of what can be achieved with great data and BI systems. So please, if you want to go on an adventure with us, please make contact through the avenues in the description below.